All right, so this question says which function or functions represent a vertical stretch of the parent function f of x equals the absolute value of x. So let me first say the parent function for an absolute value looks like a v, like this. And it can either look like that or it can be upside down and look like that. Now, for a vertical stretch, what they're talking about, so let's do this. Let's just draw this little simple graph. And so I want to show you what a vertical stretch looks like. So vertical stretch. So what's that talking about? What that means is it would take the parent function, the starting v, and it would make it wider, like so. So that's what's known as a vertical stretch. So what causes that to happen? So let's go and look at the standard form of an absolute value function. And so the standard form is f of x equals a times the absolute value of x minus h plus k. So we have these terms in here of a, h, and k, a, h, and k, and each of these affects the parent function in different ways. And so what we really want to know is which of these a, h, or k causes this vertical stretch. Well, the answer is A. A causes a vertical stretch. And so if the A value is greater than 1, so let me write that down for you. If A, that's not an A, if A is greater than 1, then that causes a vertical stretch. Vertical stretch. And that's really all you need to know for this. But I'll go ahead and tell you that if A is less than 1 and greater than 0, so if A is between 0 and 1, then what that does is it causes a compression, which would be the opposite of a stretch. So instead of the lines getting further apart in the V, they get closer together. All right, now I'll just point out real quick, we don't need to know for this question, but what the H does is it shifts this V shape, it shifts it right or left. A positive H moves it right, a negative H moves it left. The K value shifts it up and down. Positive K goes up, negative K goes down. All right, but we're just interested in a vertical stretch, so we're only interested in this term here. So the value in front of the absolute value bars. So for a vertical stretch, we're looking for an A value that's greater than 1. So all we have to do now is come over here and look at all of our functions here and see which one has an A value of greater than 1. And so here the A value is 2, so that's an answer. Here the A value is 1/2. That's a compression. That's less than 1. So that's no good. Here, okay, there's nothing there. So what do you think the value of A is? Well, if there's nothing there, there's really a 1 there that we don't need to write. And so if A is 1, which reminds me, I should have said if A is less than or equal to 1, it causes a compression. So actually, that's not true. So if A is 1, it doesn't do anything. It's just the parent function. All right. So sorry about that. So this one is not a stretch because it's got to be greater than 1. This one also has an A value of 1. This one has an A value of 1. This one has an A value of 5 halves. 5 halves is 2.5 as a decimal. So that's greater than 1. So that's a solution. All right. So make sure when you're talking about absolute value functions that you understand what these terms A, H, and K do so that you can answer a question like this. All right. So keep working hard. You're doing great. you're on your way to mastering the math.